So Lionel's a New Zealand-born Samoan, a father of three. He was telling me 3 daughters. Woo, I've got 1 daughter. I know how hard that can be. So 3, man, yeah. But he's also got a passion for design and technology. After completing his master's from Vic Uni, he launched Creative Pathways, which we're going to learn about today, an outreach program to help make 3D technology more accessible to young Māori and Pasifika students. He began to explore emerging technologies to tackle the problem, in particular the use of 3D printing to create tools and meaningful objects of value from recycled plastic. Because this could obviously be one way to help address the growing amount of plastic waste filling up our landfills and waterways, not just here, but also in Samoa and in other marginalised communities. So let's have another round of applause for Lionel as he comes up.
Can you guys hear me? Yeah, all good? Sweet. Tala lava mo lausi ni le tu tato kata se le tsa ya o api api. Me no ni ngorwa tato mo mo ma ni usana tonga ma pali u manono. Kia ora pete ka tō rong tu ingo. He kata waka ki nei te he waka. Fora ke has to out of the way, get the stuff out of the way. Pretty much my name's Lionel. Pretty much basically for starters, pretty much on the all right. But pretty much, yeah, as spoken, I am of Samoan descent. I actually work for this university as well, in terms of a student recruitment officer, now known as a future student advisor. So if you guys are wanting to come study here, come talk to me afterwards, yeah? Just putting a quick plug in. Every time I bring up this photo, it's quite fraudulent because I don't have the dreads anymore. The dreads are gone. The dreads are gone since October last year when I did a fundraiser just for cancer foundations and stuff. They just had to get rid of me. Also, getting sick of the kids pulling my hair as well. All right. So pretty much, I'll talk about real quick a little bit about myself. All right. Just so you guys don't feel like I'm a random dude who's just come off the streets. You guys probably wondering while I was eating bagels upstairs, who's this guy? I'm here for a reason. Hopefully it makes an impactful sort of little, however long I've got with you guys, hopefully it makes a little bit of an impact in terms of just taking something back with you guys, okay? So that's my family up top, in the top left-hand corner. Got 3 girls, 2 of them are my partners, 1 of them is mine. You can probably tell which one's mine. The one under my arm and the one. No, actually it's the one in the middle. I'm a boxing trainer behind the scenes as well. In the gym in Lionel, boxing trainer out there. But my big passion is about design. How can I use design in a way that can help impact not only communities, create opportunities, but just for a better future, okay? As spoken about as well, I'm part of the sort of team here at the university as well. Studied here, went to Seattle campus, which is down on Cuba Street. You guys are from here. Most of you guys from Wellington? Yeah, cool. So if you guys are up Cuba Street, you'll probably see our big red building on the left, big Clifford building. Okay. So pretty much starting the talk is how did it all start? Yes, it was spoken about in terms of creative pathways, in terms of the stuff that I did afterwards. But in terms of relationship to this conference and to the session that we're running in terms of sustainability and the environment, I thought I'd talk about the big research behind the scenes, how it all started. Back in, oh man, just going back a few years now, 2013, yeah? How old are you guys? Maybe not team. Well, that answer that question could just make you feel older. All right. But how it all started was pretty much on YouTube and stuff. Yeah, just going through random videos online, seeing heaps of the stuff pop up on my Facebook feed and all that kind of stuff. In terms of plastic waste, in terms of the impact that it's making in our environment. Yeah, we've seen a lot of these photos. We've seen even down our local beaches. Even going back to when I was in primary school, I remember our school always taking us down to Petone Beach, doing beach cleanups. Yeah. We'll always go back with massive bagfuls of rubbish that's just been left behind or even just swept up from the beach. There's that documentary as well, Plastic Paradise as well. If you guys haven't seen it, have a quick look at it. But that sort of influenced my research in terms of learning about the likes of the Great Pacific Garbage Patch. The massive gyres in the ocean sucking in a whole lot of plastics towards the middle and shooting it out somewhere else. and all those little islands that are just having to put up with all the waste that are just coming on shore. So that's how it all started. The big question for me then, after seeing all these videos, is how can I use this information? How can I take all of the stuff that I've read, that I've watched, that I've listened to in terms of, you know, just discussions and panel like events like this? How can I take that stuff, make it unique for myself? How can I translate all of that and put it into a way that's going to be impactful for not just myself, but my family and everyone around me? Yeah. Real quick question to you guys. What are some words that you guys see or sort of come to mind just by looking at this image? Feel free to shoot it out. Relaxing, cool, awesome.
Beautiful.
Beautiful, well done. Yeah. Anything? Yeah, that's the one. Real positive words, eh? Sometimes if you haven't got premium on YouTube, you'll probably see some people just running along the beach. Yeah? And all the bikinis and stuff along the beach, hard promoting like islands like this, yeah? It's always like vacation or relaxation, the blue crystal clear waters, yeah? But in reality, this is what a lot of our Pacific people are dealing with, right? So that's the outside, that's that facade that everyone else sees from outside in, and they want them to come over. But our people in the Pacific, so like I said, I'm Samoan, so my people, so when I went over for research, here's some of the photos I took. Yeah, there's a whole lot of piles of plastic just loaded up. Reason being is they can't do anything with it. Plastic is so, value of plastic is so low because you can't export. Okay, you can export, but there's no big return for our people. And saying that there's a whole lot of importation into the Pacific just to help them with just basic necessities. All right. But in talking about how do we get rid of it, that's the question that they're struggling. Okay, so for example, there's beer crates behind one of the breweries. I had a family member go back over in 2017, that beer crate pile is still there. It's probably still there right now because of the whole COVID situation, they don't know what to do. All right. A lot of polystyrene still around. That top left-hand image of the rubbish bags on top of kind of like a little plinth. That's to keep the dogs away from the rubbish. Hence why they put it up so high. Okay, so just for context into some of these images. But the main methods of disposal in the Pacific is either oceans, rivers, and lakes in the landfill. They're either buried as well or they're burnt. Okay, those are the main ways of getting rid of rubbish. All right. In terms of recycling and separating, that stuff doesn't really exist. Again, there's not enough jobs as well, not enough infrastructure to run all of that. Okay, plus again, the return is real minimal if they're trying to export these materials overseas. Metal's not too bad, okay? But in terms of lightweight materials like plastic, it's hard to motivate our Pacific people to actually do something. So that's what I did in terms of trying to figure out, cool, I've seen all these videos on YouTube, plus the discussions that I've read and also listened to. I found the issue in terms of impacting into not only my people, but across the Pacific. And keep in mind, not just Pacific, think about those other isolated countries around the world. Yeah? So cool, you found the issue, now what? And that was the big question in terms of figuring out what I was going to actually research for my master's project. And that's where we did a little bit of digging, found out that the first sort of recycling machine for 3D printing was actually made here in Wellington at our campus. And it was taking, what can I do with my design background, being an industrial designer? How can I take that to approach sort of that issue that I've found, okay? So going off the initial specs and initial research that we did at the School of Design, a few years before I came in terms of the first recycle block, what they came up with was taking that plastic material, shredding it up, okay, whether it's into pellets or into little scrap plastics, melting it down into what we call filament. So filament is what we use as ink for our 3D printers. Has anyone 3D printed before? Awesome. So a lot of this will probably make sense to you guys, yeah? In terms of the material, melting it down. For those of you who don't know what 3D printing is, think of an ice cream machine at Macca's, yeah? You've got the base, which is a cone, you've got the ice cream that's coming through, and the mountain just builds upwards. Sometimes it does stuff up, like the ice cream machines at Macca's, all right? But just like pretty, you can go back and fix it, yeah? But yeah, so this is the sort of process that we wanted to take advantage of, okay? So it's taking advantage of, yes, it was created here in Wellington, it's been pushed a little bit more overseas as well, but how can we bring this as not just a student of Victoria, but also as an individual of the Pacific? How can I bring that into a context that relates to me? All right, and this is where the Indigenous knowledge and Indigenous studies that I did do focus on this stuff. So cool, we've got plastic. What can I relate to? So here's some of the other images. That was probably the most dodgiest machine I've ever used. We purchased it, it's pretty much a chainsaw blade wrapped around this middle piece, and we had to hand crank it. We popped the drill at the end, it went too fast and started melting the plastic. Okay, but it was very sharp. Got to the point where we were using coffee grinders as well. All right, shooting it up and then making the material out of it. And then these are some videos, but these are some images of the machine that we used, that we purchased from overseas. All right. So again, going back, how can I use this plus my background, my cultural background, okay? And this is where I looked into the coconut tree, also known as the tree of life across the Pacific. The reason why it's called the tree of life, it's pretty much everything from that tree can be used for something. Whether it's the wood for furniture, whether it's the coconuts themselves, the husk for fire, the husk for rope. The coconut shells can be used as bowls, also as for fire as well. Okay, you can eat the flesh from the coconuts, drink the water as well. The awesome thing with the coconut tree as well is most of it sprout from the coconuts when they mature or when they fall off the trees and sort of ferment and all that kind of stuff. I'm not a scientist, but yeah, they do something and then a new coconut tree comes up. Yeah, so that's the cultural sort of narrative that I wanted to figure out. How can I put the plastic and the coconut tree ideas together? All right. This is what I came up with. All right. This is what I came up with. Tourism at that time was real busy. It's still a big thing. We are hit pretty hard in terms of COVID, but things are slowly opening up slowly. All right. So cool. Tourism industry. Our Pacific people rely heavily on tourism. Our tourists come in, they drink a whole lot of water from water bottles. Reason being, the water systems and filtration in the Pacific isn't the greatest. All right. So if you guys ever go overseas to the Pacific, water bottles, all right, is what's most likely going to be your main source of hydration. Going through the whole process where we went through before into the shredding material, coming up with pellets, where we shreds, turning it into filament, and that's one of the first legs. We can sell that material, okay, in terms of recycled plastic for 3D printing and creating a new export. We're creating jobs in that process in terms of collecting materials, in terms of washing it, shredding it, turning it into filament, again, creating opportunities for our people in the Pacific. But we thought we'll go one step further. This is where the cheapness comes in. All right? So we take that 3D printed material, that filament, we enable communities, artists, schools, doesn't matter what kind of industry it is in the islands, to create 3D printing models, whether it's spare parts or even, in this case, souvenirs. All right, souvenirs that could be that are made of the recycled material and be taken back with the tourists when they leave. All right. So instead of taking like a turtle shell or a carving, why not take what was made out of the water bottles that they drank with that symbolize their journey, that sort of time they were with us. All right, so that's sort of that life cycle that I came up with in terms of how do I implement it in a way that relates to not just Pasifika, but also design, okay, in terms of two things that I understood. So cool, testing and outcomes. So what did I come up with? Can anyone guess what that material was? So yes, it's plastic, but what did I source it from? On the left. Can anyone guess what that initially was in terms of product before I smashed it up? Any guesses? Sorry? No.
It's going to guess the same thing.
Nah, not food. Computer keyboard. Okay, computer keyboard. Taking a computer keyboard, shooting it up in that coffee grinder, that's what I got out of it in the end. So making it a lot finer, we made a material out of it. And at that point in time, this was probably one of the few actual 3D models made using recycled materials. Anyway. All right, so that's, so this is sort of like an example, all right, real quick one. Yes, this is an old computer keyboard, and we made like a mini fish hook that could be sold online. Say that we'll need probably a bit more development in terms of making it look a bit better and more appealing. Okay, but this was the proof that it could be done. All right. Some of the other stuff we came up with as well. These were 3D scanned shells and also turtle skulls from Te Papa that we went in. 3D scanned them using our scanners, 3D printed them, and then also did a little bit of post-production in terms of just some dyeing and inking and sanding. Again, creating the narrative that the material that this is made of could have ended up in the ocean, damaging the wildlife that we've created. So again, it's education. Okay, so creating a little bit of impact in that sense. Okay. Other than just the tourism industry, what about our local community? How can we utilize this technology to help enable our community and the islands, our families? All right, and this is where we came up with, or where I came up with, so cool, this customization that is enabled now through design, through 3D printing, through design, CAD software. Utilizing traditional methods as well in terms of lashing, how can we utilize some of the skills that some of our artists did to help enable our Pasifika families? Okay, so this is what what I came up with, all right? Making something that was normally seen as just a mundane activity to record. I'm just going to go peel some taros. All right. Typically, when we peel taros in the Pacific as well, you either use the coconut shells or ends of tin cans. Right. Again, the recycling idea is already there, utilizing that scrap material. But taking into consideration those of our community who might have arthritis in their hands, might have issues with safety, and all that kind of stuff, and creating a handle and stand that can now also be utilized as a sort of talking point within their house as well. Okay, so that's the sort of thing that I decided to go through. Some of the other stuff that I came up with is what I've also brought in as well, is looking into traditional culture. All right. So these here, team, are 3D printed carver bowls. I actually pass these around. You guys want to have a look at it? These are our 3D printed carver bowls. This is made out of recycled PET, so your standard water bottles, pump bottles, H2O bottles, whatever bottles you've got. That's recycled there. The red tips at the bottom is all fabric dye. So again, post-production. All right. This one here, so yes, that one's all one color. This one shows the impurities of these recycled materials as well. Okay, so you've got this sort of zebra look to it. And that's due to the different colors of material that we pick up, or that we take and shred up. And then this is how it comes out, using that filament. So again, this one's coming out as well. Thank you. The other thing we wanted to focus on was cool. Our traditional carver bowls are made out of wood. Yeah? They're made out of wood. We're struggling in the Pacific in terms of these native woods for our carver bowls, for our different traditional tools. We're struggling in terms of not having enough of them. All right? Why can't we use some of these materials that we're trying to get rid of to make these traditional objects? So now we're challenging tradition in that sense. The reason why I keep saying we is myself and my supervisors pushing a lot of this. That carver bowl coming around now is a take on a more modern version of that, using 3D printing and taking advantage of 3D printing where there's no rafts. Some of you guys may know what that means, but trying to have as minimal waste material after it's made. All of those are made in one go. Those two plastic ones that are coming around are about 40-hour prints. That one's a 30-hour print. Yes, we were lucky not to get a power cut that night. But that's sort of the idea behind these cover boards. So that one brown one that's coming around is a mixture of both plastic and wood. Okay, so we can do a little bit of push reduction. You'll see some of the tooling marks underneath as well. But it's taking advantage of those materials and putting it in the context where now it becomes quite symbolic. The material that we wanted to throw away before has now become something that we don't really want to throw away. It's something that we know in terms of tradition. So there's some images there. That's my sister on the left, my little one, which was younger, on the right, playing around with the idea of the older generation versus the younger. All right, our older generation are sort of used to the wood, but some of that stuff, like I was saying before, is slowly becoming a bit more difficult to get hold of, and thinking about what our kids are going to inherit afterwards. There's some other images there, for example, in terms of showing context. But yeah, so that's sort of the project that I went through. That's the one that I completed. That was my master's pretty much. The awesome thing is this became the catalyst for a lot of change within the School of Design. In terms of now, we have a machine that shreds up massive pieces of plastic now at the university. So we popped one of those plastic chairs that broke because someone decided to lean on it real far back, or they're in a lowrider, snap, threw it into that, it broke it up real fast into little mini shreds in about 2 minutes. Okay, so now, yeah, so it's become a catalyst for change, this project. It's also helped influence some of our other students coming through as well. Like Sophia Cameron, who wanted to utilize Wellington communities, especially in spaces where a lot of plastic is being used, like the ASB centre out in Kilburn. A whole lot of wood models are just thrown away. There's the cafe there as well. How can we utilize materials from there past the beach to create miniature objects via design? Again, this exploration is in colour. Okay, these are some of our other explorations, so miniature lamps as well, installations. It's also helped influence the life of Hui as well. That's an example of what I was talking about in terms of different colours of materials that we had to go through after, before and after we've shredded it. These are the real filament that are made from it as well. And these are some of the products that she came up with: lampshades, lasers. And probably the latest one being Courtney Naismith, who's come through the program and taken some of what we've all done and made it her own. In the sense that she's created lampshades using recycled material, PET. This project was also in conjunction with New Zealand. If you guys flew with New Zealand a few years ago, they had a lot of those little plastic spoons for their coffees and teas, but didn't know what to do with them afterwards. So Courtney took advantage of that, took a whole lot of them, turned it into materials where she made lamp chandeliers. All right, those patterns made on those chandeliers is all based on tooling algorithms within technology. Okay, so again, taking advantage of all this tech, how can we utilize it to help us? Here's some of the other work as well in terms of utilizing, again, traditional materials, so taking parakeke and shooting that out into a powder form, mixing it with some plastic bags, and then turning them into these miniature bowls as well. Okay, so how do we utilize design in a way that can have impactful material and also create an impact in our everyday lives? And this is how we're slowly trying to create all that change, all right, within the School of Design. So cool. Some of the other outcomes and impacts, this is where I slowly start transitioning from the 3D printing design space that I do into how can we utilize this further. Okay, so real quick, the goal for that project, the cover goals in that my initial research, was to take it back to Samoa, take it back to the islands. In terms of now we're going to try and enable our communities to do all of this. One massive issue. How are they going to learn that stuff when they don't have the technology accessible or the education to help teach it? And that's where Creative Pathways was established. So we established Creative Pathways as an education tool. A tool where we go out to schools. So we initially started with Taito College here in Zaha, went to Taito College, worked with some of these students just to test out how it is easy, can it be done in terms of teaching and upskilling digital literacy to our communities before we take it to the Pacific. All right. It became a beast on its own. These are some of the sponsors we worked with at the time in terms of Akina, Vic Uni, which is now called something else, what's called New Zealand Product Accelerator, Creative HQ, Akina, and Pacific Business Trust. These are the schools that we started back in 2015, 6 schools. Tawa, Taita, St. Bernard's, which is my old school, Queen Margaret College, St. Lawrence, and then from those, we also did outreach in terms of others. So we had, I'll be honest, we didn't do any program. Schools just found out about what we're doing and just wanted us in there to help upskill not only the students, but staff members. The reason why they wanted us to is because we didn't charge them anything. We went into these schools, not charging any schools for anything. Okay, so we were paid and sponsored by the sponsors before, but a lot of this stuff was just helping create new alternatives for learning in the school system here in New Zealand. Did some work with these guys as well. These are some of the photos. Okay, so what we started to do, we started to create curriculum change in schools as well, creating courses which were, for example, in Corridor, the engineering design program. Well, now we're starting to mix design and science, so a lot of the STEM subjects. Okay, so what we decided to do was take the idea of forces in motion, mix it with 3D printing and design to design spin tops, and got all of them just to battle how long they could last. Sort of like those old Beyblades, if you remember those. Yeah. Instead of bottle caps, we got them designing and making them using 3D printing. This is the image that we like to push a lot in terms of every talk we do. Reason being, it's not only showcasing that Pacific and Māori students are enabled to do this, but it's also trying to create more numbers via females in the industry as well. All right, creating equality within that space. The awesome thing about this image too is that cool, all the girls are finished. We've got the 2 lads in the back corner still trying to finish because we're mucking around the most of the time, yeah? Which is pretty standard in schools when we go around. But it shows that stuff, yeah? And that's what we enjoy about the program and all the different students. Just myself and some of our team members, but Tony's in the middle. I'll talk about it in a little bit more. Miraz is in Samoa. So Miraz on the right in the black crew neck, he's currently in Samoa doing similar work to what we're doing here. So he's trying to establish relationships over there for us to potentially move over there. But Tony, I'll talk about soon. But the reason why I wanted to show this image, or these images, was sort of the community projects that we get some of the schools to work on. So this is a Christmas tree project. So we got the students at St. Bernard's to design Christmas tree ornaments. And they were 3D printed. They didn't know what we were going to do is we're going to print off a whole lot in terms of 80 of these prints. And we were going to give them as blanks, so one color, white, to kids in hospital. With a Christmas tree, with the idea that we're now trying to build communities of giving. Okay, allowing these students to feel a little bit of that sort of warm butterflies and all that kind of stuff. Yeah, and getting the kids in the hospital to paint them, decorate them through the struggle of being in the hospital during that Christmas period. All right, so that's one of the biggest projects that we've done. One of the ones I still enjoy. Plus we've run workshops around other community groups around New Zealand as well. In Corridor, the likes of Gisborne, Auckland, still to reach go down south and all that kind of stuff. But yeah, these are some images from there. So this is where there's a slight change. Yeah, it's a cool creative pathways established in 2015. In 2021, we decided to change up the market. All right, we wanted to make it more Pacific because we were the only ones doing it within our communities. All right, which is where Moana Innovative Learning was established. Myself and Batoni was in the previous couple of slides over. We pivoted. These are our sponsors for that in terms of the Pacific team here at university plus the University School of Design. But this was established to, again, create networks to help create impacts for Pacific Māori communities out in different high schools around New Zealand. All right, we got funding from Ministry of Pacific Peoples, plus also Vein Creative, which is a creative that Tony owns, that was part of. And again, the idea behind this was taking the initial research that I did in terms of my masters, creating all of that, moving into the spaces within Lower Hutt, Wellington, just to start off with. And the idea was, how can we utilize this more long-term? And that's when we started working into QA to create actual achievement standards that students initially get credit for. All right, so cool. We're not just a program that comes in, runs a few sessions with you, then leave. Now we're hopefully creating a system that comes in, we help upskill our teachers, upskill students as well. All right, running through QA approved subjects and courses. So now enabling you guys as students to gain these credits as well. Moving forward, so these are some of the photos from that. That's from the Hutt City Library, plus some of the squad over at St. Bernard's College. Yeah, again, utilizing 3D printing where they end up with something at the end. The big thing for this though is we're not just 3D printing junk. Is we're actually trying to put some meaning behind these objects. All right, so you're not just printing the cool object, but afterwards, hopefully keeping it to help, yeah, pretty much keeping it. Some of the engagement we've done were part of Tech Week last year as well, running workshops for that, plus the integrated modules that we do. So I talked about real quick in terms of achievement standards and modules we created. These are some of the ones that we actually created for schools. In terms of now taking the sciences of like surface radiation, so heat, conduction, convection, taking some of the science and bringing design into it. Designed via 3D printing. So if anyone knows anything about surface area, radiation, convection, conduction, everything like that, into the heat transfer, this is how we utilized it in terms of experiments. So again, students are now getting credits for this. So looking into conduction, do the wall thickness of different 3D printed models affect how quickly a cup of water at a certain temperature cools down? Same as surface area, the bottom. The surface color, so does the color of the material affect heat? And now with everything together, the density within the infill. So you'll see what it looks like there at the bottom in terms of what the infill looks like. Does that affect how quickly water goes cold and so on? Does that make sense? So that's what we did in terms of that at school, getting the students to design all of this and 3D print it themselves. So again, handing over reign to our students. Case study was knowing the enemy. So everyone's going through the whole pandemic situation. We've experienced 2 national lockdowns the last 2 years. How can we utilize this stuff we were doing way before that? So this was back in 2018, where we had a relationship with ESR. So they are out in Taito, and we work with them in terms of looking into bacteria and different viruses, pathogens, and creating 3D models for them. All right. This was this year. So we did that in 2018. This was last year, sorry, 2021. We were still running the same project. These are some of the research that the students did in terms of conducting research regarding the different viruses and stuff. And this was real weird. We started seeing the images of what COVID looks like. Skip that one. And that sort of, so that was back in 2018. That top model in the middle was this model that the student made in relation to how we started seeing COVID-19. So the awesome thing we started with in terms of 18 without us even knowing was enabling these students to actually understand what some of the stuff coming out now is about. Again, utilizing 3D printing in a way where they're now using it as a learning tool. All right. So to wrap up, that's pretty much most of the talk anyway. But to wrap up, like I said before, our team is still working behind the scenes in terms of the one learning initiative, or it's called one innovative learning. Sorry, I had a one link. So we're still working with different schools Still pushing for funding on that end as well. In terms of the recycling materials, our School of Design is still pushing that hard. Okay. So these, you guys that sort of still in my school and want us to come out to your schools, please come and see me. We'll get my contact details of the team. That's pretty much a wrap up. So that's sort of been my very long journey in terms of recycling, 3D printing, finding my issue, moving into the education space, and now slowly trying to integrate that research that initially done into recycled materials back into these school programs. Just quick acknowledgements too. These are my supervisors, Professor Simon Fraser, John McHawk, School of Design, Tony, Tavai, and some of our team from MVP as well. Other than that, I think that's me. After next week.
Some stuff. Questions?
No questions.
Lionel's really keen for lots of questions, he said.
How many bottles do you think that's going to make that bowl really?
That bowl there,
Yeah.
it's hard to remember. The best way that we can calculate it is white points. So taking into consideration how heavy a pump bottle would be versus how heavy that is would probably be the best way to figure that out. Just so we shoot it up so much. But yeah, it's hard to tell. But pretty much that's about 2 kilos worth of plastic waste. Hopefully that makes sense. I think there was a question just in front of you.
Yeah, what's the biggest limiting factor on really speeding up the manufacturing of these 3D products?
Yep. So probably the biggest, what's the biggest one? I think there's not necessarily one big issue. I think there's a whole lot of mini factors in terms of, for us to make the filament, it's got to be consistently the same thickness across. All right. At any point, there's like an air bubble that can stuff up the whole brick. That's one thing that we think of. I briefly mentioned power cuts. Wellington went through heaps of power cuts when we were going through this research. So we, again, if it cuts down in the middle, we'd probably have to go back and figure out where it stopped and start building on top. Other thing is also material cleanliness. So we legitimately have to wash every piece that we get. We slowly bake it in an oven as well, in terms of drying it, and making sure there's no other contaminants within that. Because the last thing we want to do is, again, we're 3D printing using this filament that we've made, and there might be one speck of, I don't know, water or sawdust and clog up our nozzles. There's a whole lot of different issues that we need to think about. And it's stuff that we've actually thought about too. And trying to address. The other stuff might be as simple as heat and humidity within the space that we would. But yeah, those are some of the different issues that we're having or have dealt with in the past. Pretty much the big thing was just time. Like that bowl that I told you is 40 hours long. Machines are slowly starting to speed up a little bit, but then does that alter the quality that comes out? You know, so stuff like that. And
would there be an opportunity within the schools to have like a recycling program using plastic bottles, say produced?
sorry, could you just?
Within schools, do you think there'll be the opportunity to have like a recycling program using plastic bottles or plastic products collected from the schools instead of making filaments for schools themselves to use? Do you think that'll be an option?
So that's sort of like our big goal in terms of overall. That's what we're wanting to do afterwards, is to have that recycling system. Tricky thing is, going back to the issues, is machining and how much the machines cost to do that. So whether we create an initiative where we go collect these plastic materials from schools, or we work with the likes of Flight Plastic out in the hub. So if you go to Waitangi Hill, there's Flight Plastics, the old Griffin's building. They're the main sort of recycling crew here in New Zealand, and they're running out of there. So it might be just working with them to collect it for us, and we just create the material for them, and then we give them back to the schools for programs like this, or for just projects they want to run. But yeah, that's sort of the end goal that we want to create and implement. It's just logistics that we need to figure out.
How much does it cost to run and to buy a 3D printer? Would it be profitable in the end? Because it sounds like it would be quite expensive.
Yeah, so 3D printers are getting cheaper. Alright, I think even warehouse stationery is starting to sell. You know, you can purchase some of Alibaba. The 3D printers, when I started, so go off this. So I started 3D printing in 2010. Very long time. All right. One of the small machines that we've had, that was about $5 grand. All right. The one that I've got on here, in terms of the image on here, if I can go back to it. When the first model of the Upbox came out, it was about $9 grand. Now it's about $1 grand, $2 grand. So over time, it's slowly getting cheaper because the patents that protected how these machines are made are slowly expiring. So they're becoming open source now. So people are even making stuff. There's a guy out in Jacob who's making his own 3D printers out of his garage and selling them. You know?
Is he 3D printing them?
Low key, the course of fingers, he's probably 3D printing his parts for it too. All right. But yeah, in terms of how much it's costing, keep in mind technology is evolving, it's becoming cheaper over time. In terms of how feasible monetary wise, in terms of the stuff you make, you've got to take into consideration how long it takes to print. So in terms of doing like a 1,000 run, you'll need to consider that stuff. Maybe good for the small object, like the one-offs or the two-offs, but in terms of massive industrial run line, it might be a little bit tricky. Yeah.
That's interesting though, because George Slim yesterday was talking about how part of the problem with plastic is it's got no value, and so we don't consider it. Like he said, if you were wrapping your sandwich in gold leaf, you'd keep that gold leaf because it's quite expensive. But I guess there's scarcity has value. So one-off, unique productions. Like if you're looking to get into selling stuff, if you make something that's one-off and there's never going to be another one of these ever again, that's got value. Or the other side is like your little angels, you make a ton of them and then you sell lots of them. But I think the uniqueness of some of the stuff you were creating or you have created, it's like there's value in that because it's like there's only one of them.
Yeah. And that's the tricky thing too. For example, those bulbs, the bulb with the red legs on it, that was the only one that I made for maybe 2 years. So many people saw it from our Pacific community wanted to buy it. It was hard to figure out how much it would be worth. One, you've got to take into consideration, it is recycled material. Is that a plus or is that a minus? You've got to take into consideration machine costs. The machines aren't cheap as well, you know? So there's a whole lot of factors in terms of trying to figure out how much the stuff is worth as well. And saying that those are the only 2 recycled colour bowls, there's people still hunting me down to try to buy them off. I'm not selling them. Because it has that value to it for me, in terms of the time and effort I've implemented into it, and just sort of the story that it tells. You know, just going back to the image of my daughter and my sister. You know, so that has that kind of value to it. Yeah. Any questions? I was wondering you guys had some questions.
Why would businesses like, I know that you frequent, like, would other businesses like, think, is 3D printing like the easiest way to use recycled plastic, like more and stuff, more easy and more profitable?
Yeah, it has its positives and negatives. For 3D printing, for us, keep in mind, I only did this, the 3D printing space as a way of, so we normally use it as a way of getting test runs before we go to production. It's quick mock-up models. But then we've sort of taken it in a way that, cool, we can start making actual objects out of it. So versus stuff like industrial molding, yeah, there are pluses and minuses there as well. So like if it's furniture and seats that you want to do, cool, that'll be probably more profitable within that space. I think the main focus should be, rather than what's more profitable, is how do we utilize the material to get the best sort of the best value out of it in terms of the material. You get me? So yeah, it has its, both of them have their sort of ups and downs. But I think if you're looking at more industrial scalability, 3D printing, you've still got a little bit of time to catch up. There's no question. How much plastic waste is actually viable for you? In terms of the stuff that we did, like viable in the sense of a return or viable in the sense of how much we get up?
Oh, no, I mean, so like obviously the water bottles and things, you're able to break those down to be cost and like polystyrene, you know, so sort of saying like, how much of the plastic waste out there could we actually use?
If it's your PETs, HDPEs, so you're like LDPEs, which are your like milk bottles, bottle lids. You guys remember those milk bottles that they released with like the no light for it? And just like an inner layer? Those are shit, you can't use them. Because there's now a new material inside that doesn't allow you to make it what we call virgin material, which is one singular material. There's now this other one that's contaminated. Materials like polystyrene does become quite tricky, just because of its, to be honest, polystyrene is just trash. It's shit. You know, can't do much with it, which is why we try and stay away from it. Stuff like, what's it called? Stuff like ABS, so what your Legos are made of. Legos are made of. You can use that. Saying that you've got to take into consideration some of the contaminants that come out of it when you heat it. Okay, so there's a whole lot of plastic material you can use. You just have to implement what you need to make it not only safe, but also, you know, good quality in terms of the income as well.
Do you think this alternate method of making filament out of recycled materials, because I assume most is made out of PVC and use plastic straight from the oil, will this new method, you think, become more prominent and prevalent?
Yep. And it's already started happening. In terms of there's a group up in Auckland who are actually selling the material. You know, they've even got this light green tint, and that's based off just Sprite bottles. You know, so it's, and then I think when I was studying, Lionel had a 3D printer that was based on the Coke bottles. He was trying to sell that. So it's been around, the notion's been around. But I think for me, in terms of the team, it's cool. We can 3D print with recycled material, but what are we actually going to make? Is our big focus. Because cool, we know you can recycle material, you know you can 3D print on it, but what's the end goal? The last thing we want to do is, like I was saying with the school sort of workshops, is we don't want to be making rubbish. We don't want to be getting these students, seeing these students out of design, but they're just making more trash. It's just going to be in this loop. How can we get or educate students to design meaning? And that's sort of the bigger, longer impact that I reckon should be more focused on. You hear me?
Have you had any engagement with any, like you talked about Sprite there, have you approached or have any big companies approached you? Because that was a topic of conversation yesterday was, you know, how can we influence governments and then big companies? Because like communities relatively, you know, you can go and see your local community, you can go back to Samoa. But yeah, have you had any, Coca-Cola come and said, hey, take our bottles?
Yeah, so we've had discussions in the past. So like, for example, Courtney Niceness project, to work with New Zealand to the tourism industry. We also had discussions with Food Corp. The ones who look after Pepsi.
Fruit Corp.
Yeah.
Yeah.
We'll forget what their name is. But yeah, we had discussions with them at one point as well. In terms of, cool, you guys have all these materials. If they end up with flood plastics, and that's how we were trying to figure out that relationship. Bits and pieces fell through here and there, because it is a massive giant. This is just a little group of us from Vic Uni, you know. But yeah, discussions have been made in the past. It's probably stuff that our university is starting to push as well in terms of School of Design. They've got massive relationships with the likes of, Fisher & Paykel Healthcare as well, in terms of just doing test models for them using recycled materials. But yeah, there has been discussions. Anyone here? Yep.
You think if you did like partner, like
work within those companies, do you think it will be more likely that will be more interested in getting recycled products to use or getting their products to recycled?
Yeah, that'll probably be something we'd have to sit down with the team and talk about. Reason being is, it's more than just the water bottles that we see on the shelves. The other stuff we need to think about is how those bottles are made. So normally how they're made is they look like little test tubes. Yeah? And what they're blow molded into that form. There's a whole lot of scrap of those ones that's just chilling on the side. So whether we take advantage of that material because they can't be used for blow molding, because at the end of that material that they use for water bottles ends up in consumers' hands. And that's where it's hard to sort of figure out what's happening there. The other big thing to take into consideration too is the recycling system in New Zealand has changed the last few years with China saying no to a lot of importation of plastic waste into China. They're now starting to figure out, cool, what can we do locally? So that's why teaming up with the likes of Flight Plastics out of the hub helps us. But yeah, like I said, it's one of those things we need to sit down and discuss as a team with that core, figure out, cool, do we focus on the material that's going onto shelves, or is it more the off, throwing away stuff, scrap material that we focus on? For me, it'll probably be the scrap material that's just going to be sitting there or burnt later on, you know? Good question.
I reckon it's, oh, you got one more? Yeah.
How strong is this 3D printed stuff going to be able to be used in other things besides what it's currently being used for, like industrial components or parts of wheels?
Yeah, so in terms of, 3D printing, keep in mind, this is only one of the outputs for 3D printing in terms of plastic. It could be just utilizing, through this method, using recycled plastic as test models, moving into other materials for the big execution in terms of the big model. For example, what we used to do was with 3D print in plastic, just general plastic and recycled stuff. And then what we'll do is we'll send them to get printed in metals or titanium. So for like healthcare, there's a lot of testing on our end through store design, just making hip joints, all that kind of stuff. And in industry, they're actually 3D printing titanium hip joints, all on socket. And that's sort of the idea that we're trying to do. Is cool. We'll test it on these smaller machines, but there's a bigger space as well. Saying there too, I think the thing I should start with is this isn't the only option in terms of recycling through 3D printing. This is sort of just an example of what can be done. Not the only option, not the only end goal, but in terms of just how we've taken the idea and implemented in a way that's going to help and relate to us.
I think it's afternoon tea time because it's been like an hour since you've all eaten. So cool. Hey, Lionel, thank you so much. That was awesome. Big round of applause for Lionel. So yeah, afternoon tea, and we'll get you back here at